Hello everyone, welcome to the next lecture on the PY question series. Today, based on your request, I will upload the next lecture on the number theory. I will cover all those questions from the CSIR NET 2011 to 2023. This is the part 1 of this number theory PY question series. After this lecture, I will upload the part 2 also based on your comments and live. Myself, Dr. Harish. You can find me on my YouTube channel, Dr. Harish, where you can find the playlist of CSIR UGC NET. In this playlist, you can find the various lectures related to the PY question series, and you can see each video is explained with the help of the shortcut tricks from the 2011 to 2023. I hope you can subscribe my YouTube channel so that when I upload my next video, you will get the notification. Now, before I directly move on the PY question series, let me give you some tips so that you can solve each question with the help of the 10 to 15 second time period. You must watch this video till the end so that you can learn many shortcut tricks how you can handle the number theory related problems. Whenever we are talking about the number theory, the first thing, the most important thing come in your mind is Euler function. What is Euler function is? That is what is Euler function is? That means if you define the Euler function of the n, that means all those natural number which are less than or equal to n and their GCD is 1. Also, we know if you have a natural number n, then by the fundamental theorem of the arithmetic operations, we can write each natural number as the product of the prime numbers. Fine. For example, if I write as a 12, you can write as a product of the prime number. You can write as a 10 as well. 2 raised to power 1, 5 into 1. 2 and 5 are prime number. Similarly, 18, 2 into 3 raised to power 2, and so on. Once you can decompose this natural number into the product of the prime numbers, then you can calculate the value of the phi n by using this formula. What is the meaning of that? If you want to calculate, say, phi of 10, firstly your target is to write in the product form 2 into 5. Then look at the power of this. Power is 1. So I can write as a 2 into 5, that is a n, the same number, into 1 minus prime. 1 over 2, 1 minus prime. So the answer will be 4. Similarly, if you want to write as a phi of 12, how you can find that? I can write this is 2 into square, 3 into 1. That's a product of the prime number. Then I can write this is into 1 minus prime. Prime is my 2 and second prime is my 3. So 1 minus 3. So I can say this is my 12, this is my half, this is my 2 over 3. So 6, the answer is 4 is my correct answer. Fine. So this is the way you can compute the product, the Euler function phi is the way. Now, remember always phi n is an even number whenever n is my greater than equal to 3. You can see I have taken the 10, answer is even, 12, answer is even. But make sure it is always n is greater than equal to 3. If you want to find the phi of the prime number, any prime number, say 5. So it is already written as a 5. So I can write it 1 minus 1 over p by using this formula. So that again come as a 4. So if you have a prime number, then it will be my p minus 1 always, provided p is my prime. Fine. If p is not prime, then you can use this formula. If you have the two numbers m and n such that their GCD is 1, then phi of mn is nothing but the product of their phi. Another definition that come in mind is the number of the positive divisors. How you can compute the number of positive divisors? If, for example, if you have the, you can define the positive divisors is, that is a k1 plus 1, k2 plus 1 and so on. Again, the same example I have taken. If you want to find the sigma, if you want to find the tau of 10 or d of n, that will be 2 into 5. Now what will be the power is 1 and 1. So the answer will be 1 plus 1, 1 plus 1. That will be my 4. Similarly, if you want to write the 12, then it will be 2 raised to power 2 into 3. So that will be 2 plus 1, 3. And it's a 1, 1 plus 1, 2. That is my 6 is the right. Another definition is sum of the positive divisors. Whatever you have obtained These are my divisors. And what will be the sum? You can find the sum will be pi's raised to power ki plus 1 minus 1 over pi minus 1. If you want to find the number of the if you want to find the product of the positive divisors, instead of the sum you can write as a n d raised to power n divided by 2, where d of n is calculated by this form. Now another concept that is needed in order to solve the number theory problem is Euler theorem. You can choose any of the integer and any of the positive integers such that the GCD is 1. For example, if I choose a is my 2, n is my 3, clearly say the GCD will be my 1. Then you can say this result always true, and that is called as the Euler theorem. Make sure this phi is called as the Euler function, which is already obtained as I define you how you can compute them. It will be my p raised to power k into 1 minus this form. On the other hand, if you have the prime number, then as I told you, what is the phi of p? Phi of p is my p minus 1. So I have replaced this as a p minus 1. Make sure the converse of this is not true. Another one is, that's a Wilson theorem. That's the most important theorem. Wilson theorem say if n is my prime or any of the prime number, then this result always hold. And moreover, the converse is also true. What is the meaning? If this result hold only for prime, fine, because whatever the n must be my prime. Another thing is, that is the congruence. First of all, you must remember that if I written as x is a mod of p, what does the meaning of this a? A is my remainder when you divide x by p, fine. For example, if I say 10 and it will be my mod of 3, what will be the remainder when you divide 10 by 3? So the remainder is 1, fine. Now same thing for here. How you can define the solution? This congruence has a solution if you find the GCD of coefficient of the x and modulus value, fine. If this quantity will divide by this number b, then you can say this equation has a solution, otherwise not. If you have the system of the concurrences, then it has a unique solution if and only if. Again, you can find the GCD of, in this case the coefficients are my 1, you can find the GCD of m1 and m2, and it must divide by a1 minus a2, fine. Make sure the system of the concurrences is used as a if and only if. Sometimes this is also called as the Chinese remainder theorem. Now based on these simple concepts, I can solve each PY question in a simple manner. I hope you can like and comment on my this video. If you are new to my YouTube video, you can scan and join my WhatsApp. Make sure student, this is my part 1 on the number theory, fine. I will upload the part 2 after this lecture only if I get a good likes and comment on this video. If you want to I upload this lecture within the 1 week, you must like these videos and comment on this video. You can share this video with your friend. I will upload the next video on the number theory within the 1 week. Now let's start with the PY question series. The number of the 4 digits, this is the 4 digits with no 2 digits common. There is no repetition. So first of all, what will be the possible choices? The possible choices are, out of these numbers, how many choices are there? So the total numbers are my 10, fine. Now look at that. How many choices for the first digits? Definitely the first digit can never be 0. Because if the first digit will be 0, then it will be my 3-digit number. Like you can see, it is my 3-digit number, but we need a 4-digit number. So how many choices for the first place? 9 choices, fine. How many choices for the second place? Now, because 1 digit is my freeze and no 2 digits are common, so that means the second choices are my, again 9, because if I say I have fixed this number as say my 4, fine, then for the next place it can never be my 4, so the choices are my 9 again. So first of all it is 9, fine. How many choices for the third digit? 8. because I have fixed the 2 digits, there is no repetition, and for the last digit is my 7. So how many total numbers? It must be this case. So if you multiply them, it will be my 453 into 6. That is the A is my right. Otherwise, you can also discard the option. You can see it is my even number. Once you multiply this 8, the number must be the even. This number is not even. You can see this number must be divisible by 9. This number must be divisible by 7 as well. So you can write answer A is my correct answer. Look at the second option. The last 2 digits of this. First of all, what is the meaning of this? That means if you, the last 2 digits, that means your target is to find what is the last 2 digits of any number. That means this and this 2 number. That means it will be my 100. 100th place. So that means your target is to find the remainder. Fine. Now whenever your question is related to this kind, you always apply the Euler theorem. What is Euler theorem is? You can see what is the GCD of 7 and 100. It will be my 1. Fine, because 7 is my prime number. So once is a GCD is 1, so you can say 7, phi of 100 is concurrent to 1 mod of 100. So can you find the phi of 100? Phi of 100 I can return this is 4 into 25. Fine. How you can find this value? 2 square into 5 square. 1 minus 1 over p. 1 minus 1 over p. So this will be my 100. This will be my half. This will be 4 over 5. 5 to the 10. So that will be my 40. So that means 7 raised to power 40 is concurrent to 1 mod of 100. Fine. Now your target is to make them as a 81. How you can make them? I can scale them. If you scale them, 1 square will always be the 1. And then I need a 81. I can multiply both sides by 7. So the right answer of this problem is, you can see it is my 7. So the first answer A is my correct answer of this problem. Always apply the Cauchy, always apply the Euler theorem. The remainder when 16 raised to power 2016 is divided by 9. Fine. So again check what is the GCD of 16 and 9. Again it's a 1. Fine. So once is a 1, I can apply the Euler theorem. 16 phi of 9 is concurrent to 1 mod of 9. So what is the phi of 9? 9 I can written as a prime number as a 3 square. So phi of 3 square will be 3 square into 1 minus 1 over 3. So that is a 9 into 2 over 3. That is my 6. So 16 raised to power 6 is concurrent to 1 mod of 9. Now since I need a 2016, so what should be the power of this? I can divide this 2016 by 6. So 6, 3, 18, 21, 6, 3, 18, 36. So I can power them on both sides by 3, 3, 6. Again 1 raised to power is again 1. So that will be 9. So that means 16 raised to power 2016 will be my 1 mod of 9. So remainder will be my 1 is the right. Make sure student, since right now you are in the 2024 year examination, so you can do the practice like 16 raised to power 2024. What could be the remainder when you divide by n? The last 2 digits of this number. Again, your target is to find the remainder last 2 digits. That means 100. Fine. Again, you can see the GCD of 3 and 100 is 1. So I can say phi of 100 is concurrent to 1 mod of 100. What is the phi of 100? So again, as I calculated previously, so this is my 100. So it will be 2 raised to power 2 into 5 raised to power 2, 1 minus half, 1 minus 1 over 5. So that will be 100 into half into 4 over 5. So that is my 40. 3 raised to power 40 is concurrent to 1 mod of 100. Now Your target is to make them as 2019. I can divide by 40 and see what will happen. 40 into 5 is 219. So I can raise to power 5 on the both side. Sorry, 50. Fine. So I can raise to 50 power on the both side. It is my 2000 is concurrent to 1 modulus of 100. Now I need as a 2019. So that means I need to compute 3 raised to power 19 power more. So how you can do that? I can see 3 raised to power 3 is 27. 2700 is again no. So I can do as 3 raised to power 4, 81. 81 modulus of, or I can written as a minus 19 modulus of 100, or what is the 3 raised to power 5? 3 raised to power 5 is 243. So once you divide them as 100, the what will the remainder is 43. 43 modulus. Fine. Now I need as a power 29. So I can scale them. What will be the scale of 43? 43 into 43, 129, 17. Since I divided by 9, 4, 8 and 2. So that means the remainder will be my 49. Fine. Then I can again, you can see I can multiply them. It will be my 3 raised to power 15. So again 49 into 43, 9, 3, 27, 14, 36, 16, 19. So that's a 07. Fine. So the remainder will be 07 mod of 100. Now I need a 19. So that means I can multiply by 3 raised to power 4. So 3 raised to power 4 will be 81. So 81 into 7. 81 into 7. 7, 8, 7, 56. The remainder will be my 67 is the right answer of this problem. Because 2000 is here. This is a 3 raised to power 19. I can multiply them. So the answer will be 67 mod 100. So the right answer is D is my correct answer. The unit digit of 2 raised to power 100. That means unit digit. What is the unit digit means? That's the last number. That's a ones place. You have to divide by 10. Again, what is the GCD of the 2 and 10? Not 1. Then you can't apply this method. Then how you can do? You can see 2 raised to power 4 is my 16. 16 will be concurrent to 6 mod of 10. Make sure student, whenever you will see either as a 1 or as a 6, either the mod of 10 or you can see either as a mod of 10. Fine. Then whatever the power you will think about of this, whatever the power, if power may be the 1000, power may be the 7, power may be the 1 lakh, answer remain the same. Power remain the same. So your first target is to make them either as a 1 or 6. Now since it is a 6, then I can simply take 2 raised to power 25 on the both side. So since 6 raised to power 25 is always with a 6 to the modulus 10. Only two numbers either as a 1 and 6. So that will be my 2 raised to power 100. The right answer is my 6 is the correct answer of this problem. Make sure if the GCD is not 1, then you are unable to apply the Euler theorem. Then you can start with this quantity. Look at one more example. The last digit of this quantity, 2 raised to power 38, last digit, that means modulus of 10. Again you can see the GCD of 38 and 10 is not equal to 1. So that means Euler theorem is not applicable. So let's start with this. 38. Your target is to make either as a 1 or as a 6. Fine. So 38 modulus, the last digit, modulus 10. How you can do that? It will be my 8, or I can written this number is minus of 2, because minus of 2 calculation is easier than of the 8. Fine. If I scale them, what will happen? It will be my 4 plus of 4. Fine. Then if I again scale them, it will be my 16. Fine. What is the 16 modulus? What is the 16 modulus 10? 6. Now once I made as a 6, whatever the power we can take on, it is always same. Now I need a 2011. I can see what will be the number. 5 4 20, 1 11 4. So that's a 502. If I raise to power 502 of 38 raised to power 4, then it will be 2008. The number is remain the same. Fine. Then only I need is 38 raised to power 3. Fine. You can see 38 raised to power 2 is my 4. What will be my 38 raised to power 3? If I multiply them both, it will be my minus of 8 modulus of 10. What is the minus of 8? It will be my plus of 2. So that means I can write 2011. It will be my plus of 2. This is plus of 16. I can multiply them. It will be my plus of 12. So what will be the remainder? That's my 2. So 2 is my right answer of this problem. Fine. This is 30. This number will be my this quantity. This number is here. If I multiply both values, the left hand side will be my 11. 6 into 2 is my 12. So that's a 2 is the correct answer of this problem. Which of the following primes satisfy the congruence this? Again, you can see 13 is my prime number. Fine. What is the GCD of A? A of 13. Fine. So then by the Euler theorem, A raised to power 13 is congruent to 1 modulus of 13. What is the A raised to power? What is the phi of 13? Because it's a prime, it's a phi of A raised to power 2, congruent to 1 mod 13. Since I needed 24, I can scale them because the right hand side is 1, so there is no change. It is my 1. Fine. Now you can compare this value. What will happen? 6A plus 2 is congruent to 1 mod of 13. Now look at the option which was the following satisfied. Firstly, I can try to make this as a simpler one. I can use as a modulus 13. It is my 2. It is my 13 3 is 39. It's a 8. It will be, if you divide them, 16 by 3, 16 5 65. It is my 2. If you divide 83 by 13, so it will be 78 5. It is my 5. Fine. Now look at the options. If you substitute this value in this expression, we will see. First value, if you substitute as a 2, it will be 6 to 12 plus 14. Is it congruent to 1? Yes. You can see satisfied. So the first option is the correct option. Look at the second. If you substitute 8, 8, 6, 48, 48, 50. What is the congruent to the modulus 13? If you divide them, it will be 13 into 4 is 42. Then it will be my 8, which is not equal to 1. So the second option is cancelled. 2, 6 to 12 and 14 satisfied. Look at the fourth option. 5 is a 30 and 32. What is the congruent modulus 13? Is a 13 to the 6 is a 6, but I need a 1. So that option is cancelled. A and C are my right answer of this problem. Whenever you will see raised to power and the modulus, always apply this reserve. Look at this another one. Again you can see the modulus. Fine. So S is the set of the polynomial fx. What is the degree of the polynomial? Is it given to you? No. So I can choose any polynomial. Say a plus bx. What is the restriction of that? They are my integer coefficient. That means a and b are my integers. Satisfying this condition, which of the following are my true? S is the collection of all those fx. A singleton, empty, finite, countable. What does it means? That means when fx divided by x minus 1, then the remainder will be 1. And what does it means? When you divide fx by x minus 3, remainder will be 0. So what does it mean? If you think about the polynomial, what does it mean? F of 3 will be 0, because if remainder is 0, that means 3 will be the root. What will happen? Remainder is 1, that means f of 1 will be my 1. Fine, that means f of 1 will be my 1. So if I substitute this value in this expression, the first value will be f of 1 will be my 1, a plus b is my 1, f of 3 is my 0. So if you subtract them, what will happen? Minus of 2b is equal to 1, b is equal to minus 1 over 2, which is not integer, but I need an integer. So that means is there any value of the fx? So that means there is no fx exists. So once there is no fx exist, what is the set S? What is the cardinality of this? Is an empty set. So A is my right answer of this problem. A very simple example, as I told you in my previous lectures of the real analysis, linear algebra, continuity, every time I choose a particular value of the fx. Fine. So you can see there is no such fx exists. So it can never be singleton. It is never be the finite. It can never be the countable. So therefore the right answer is empty is the correct option. For the positive integer m and n, GCD is denoted as the greatest common divisor. Let m is greater than n such that the GCD of m and n will be my 1. So that means if I choose m is 4, n is my 2, which is not possible, because the GCD will be my 2 and that is not possible. Then which of the following statement are my correct? I can choose any number. Say m is my 2, n is my 1. Fine. Remember, if you choose as a particular value, your target is to discard the option. What is the first answer? GCD of m minus n. GCD is 1. Fine. So, but we can't discard them. Look at the any other example. If I choose m is my 3, n is my 1, 3 minus 1, 2, 3 plus 1, 4. GCD is my 2, which is not equal to 1. So the first option is cancel. GCD of m minus 1 can have a prime divisor. It is not always, can have. You can see 2 is my prime number. Fine. So 2 is my prime divisor. So yes, it is also the correct option. There exist a numbers x and y such that, always remember, what is a shortcut trick for you? Ax plus by is equal to c. This equation has a solution when GCD of a comma b divides c. Fine. Now look at this. What is the coefficient of the x? N. So that means your target is to find the GCD of n and m. What is the GCD of the m and n? Is a given that it's a 1. Then 1 divide 3, because right hand side says yes, it is 1 is always divided by 3. Yes, it's the correct option. GCD can be an odd prime. Okay, can be an odd prime. You can see that we all know what are the prime numbers? 2, 3, 5, so on. The only prime which is even is my 2, while rest of them are my odd. Fine. So can it be a prime? Odd prime. So let's say D is my GCD of m minus n, m plus n, which is my odd prime. That means I can assume D is my odd. What is the meaning of the GCD? That means D divides first number and D divides second number. If D divides A, D divides B, D also divides its sum. But D is my odd number, so therefore D can never divide 2, therefore D divides M. Similarly, I can use as a subtraction also. D divides N also, so that means D divides GCD of the M and N also, but the GCD is my 1. Fine. So therefore D divides 1, which is not possible, because it is possible only if d is my 1. That means d can never be an odd prime. It's an odd number, but it is not a prime. Remember, 1 is neither the prime, 1 is not a prime number. So that means this option is cancelled. Correct option are my B and C are the right answer. Okay, the number of the multiples of, what is the number of the multiples? That is a k times 10 raised to power 44. That is the multiples of that divides 10 raised to power 55. That's the question. Number of the multiples. That means they are talking about the number of the divisors. How many numbers which are divides of this? That means k divides 10 raised to power 11. That means we are talking about the number of the positive divisors of 10 raised to power 11. So how you can find the positive divisor? That is d of, I can firstly write this in the prime numbers. It's a 2 into 5. Fine. What is the formula for the d, or called as a tau? Fine. That's a power. Whatever the power is there, this is the plus 1. Power plus 1. So what is the right answer of this? 144 is the right answer of this problem. I hope you can like and comment on my video. I will upload the next video based on your likes and comments only. Okay, look at this next one. The number of the words that can be formed by the permutating the letters mathematics. M-A-T-H-E-M-A-T-I-C-S. So firstly find how many total numbers are there. What is the total words? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Fine. These are the 11 numbers. Now how many repetitions? How many times M occurs? M occurs 2 times. A occurs 2 times. Capital T occurs 2 times. H occurs 1 time. E occurs 1 time. M is already there. I occurs 1 time. C occurs 1 and S occurs 1 time. So what is the number of the words? What is the shortcut tips for you? You all know the total number of the words is a permutation. So it's a 11 factorial divided by its repetitions. 2, 2, 1 factorial, 1 factorial. 1 factorial is always 1, so there is no need to write 1 factorial. That means 11 factorial. 2 factorial is my 2 into 2 into 2. So definitely 81 is not the right answer, because you can see 11 factorial is a very large number. If you divide them by 8, it can never be these two numbers. The right answer is B is my right answer of this problem. Number of the positive divisors. Your target is to find the d of n or tau of n. What is my n is? 50,000. Firstly write in the prime factor. So that is 10 raised to power 4. 10 I can written as 2 into 5. So I can written is 2 raised to power 4, 5 raised to power 5. So what is the d of n? The power is 4 plus 1, power is 5 plus 1. So that will be my 5 into 6, 30 is my correct answer of this problem. You can see very simple approach. There is no need to think about that. Just remember my initial given you some tips. The smallest positive integers in the given equation. What does it means? What is the question meaning is, if you substitute like 24x plus 60y plus 2000z such that x, y and z are my integer. They are not positive integer. It may be positive or negative. That means if I substitute each number, if I substitute x is my 1, y is my 0, z is my 0, then answer will be 24. Similarly, if I substitute x is my 0, y is 1, z is 0, answer will be 60. If I substitute x is my minus 1, y is my minus 2, z is minus 3, you will get some another number and so on. Fine. So out of these numbers, what will be the smallest positive integer? What will be the smallest positive integer? So I will tell you the firstly shortcut tricks. Whenever you have the series like AIXI, fine, where AIs are the integers, XIs are my integer, or these are my positive integers. The same form, I can write 24 as a A1, 60 as a A2 and so on. Then the number of then the smallest positive number is my GCD of AIs. That's a simple shortcut tips for you. The smallest number will be the GCD of AIs. So now, what is the AI in this case? AI is my 24, AI is my 60, AI is my 2000. Fine. Now what will be the GCD? The first way is you can compute them GCD as you did in your 9th or 10th class, but there is no need. Look at the option. 24 is not divisible by 60, so that option will be cancelled out. Fine. 6 is not divisible by 2000. This option is cancelled. 4 is divisible by all. 2 is divisible by all. Since we need a greatest common divisor, so 4 is my right answer of this problem. So the right answer of this is 4. Otherwise you can see 15, and you can see none of the number which is common to divisible by all. So the GCD will be my 4. Remember, this is my shortcut tips for you. Okay, now another one. Let M is a collection of all those tuples such that sum of them will be 6. Then the number of the elements in the M. Very, very simple. You can get your answer in the 10 seconds. But if you think about that, I can substitute one value, like if A1 will be 1, then this number will be my 2, this number will be my 3. That is my one possible choice. Another possible choice will be my 2, 1, 3 and so on. But that will take a very, very lengthy calculation. If in the examination somebody will give you as a 16, somebody will give you as A1 plus A2 up to A9 is my say 100, then it is not an easy task for you that you can select by hit and try. So what is the shortcut tips for you? Always remember, whenever you want to find the number of the element in this equation, so that means whenever it is my A1, or instead of the A, I can write in terms of the X. X1 plus X2 up to the Xn. If this number sum will be my K, then the number of the elements is a very simple approach is K minus 1 combination N minus 1. Fine. K is a sum, N is the number of the tuples. So what is the K and N in this case? Now you can see K will be 6, 6 minus 1 combination, N will be my 3, 3 minus 1. So what is the answer of this? 5C2. That means 5 into 4 into 2 into 1. So what is the right answer of this? 10 tuples are there which will satisfy this condition. And you can see, you can solve this problem within the help of the 10-second, maximum 10-second time period. So that's why I'm asking you, you must watch this video till the end and don't forget to like and comment on the video. Okay, the total number of the positive integer solution which will be satisfied this case. Again, a very simple. Can you solve this with the help of the 10 second? Yes, you can. What will be the possible choices? You can see either this is my x1 plus x2 plus x3. This will be y1 plus y2 plus y3 plus y4. The product of them will be 15. What are the possible choices? Either it will be 1, it will be 15. Either this will be 15, this will be 1. Either this number will be 3, the sum will be 3, and this will be 5, then it will be the 15, and it will be 5, it will be 3. Fine. Now, the sum of the positive integers. Fine. That means I have chosen 1, 2, 3 and so on. In the previous example, the integers are fixed, only 4 integers. But right now, it has infinitely integers. Can you think about that? the sum of the positive integer be the 1? Not possible, because if you choose x1 as a 1, other element can never be 0 because they are positive. So that means this case is not possible. Similarly, this is my 1. This case is not possible. Fine. Similarly, you can see about the 3. The sum will be, the 4 elements are there and it is a 3. It is not possible. 5, that's possible. 3 is possible. So the only choice will be the sum x1 plus x2 plus x3 will be 3 and y1 plus y2 plus y3 plus y4 will be my 5. Fine. Now once you know how many choices are there, again I can apply the same formula. The sum will be my k. So this will be k minus 1 c n minus 1. So that will be my 1. For this case 5 minus 1, 4 minus 1. So 4c3 will be my 4. So what is the right answer of this? 1 into 4 is the correct answer of this problem. Now this is a way you can solve this in a very simple manner. Now I hope in the examination, if somebody will ask you instead of the 15, if somebody asks you the 25, you can choose the factors and look at the pairs in a simple manner. Don't forget to like and comment on my video. Given a natural number n such that n minus 1 factorial is concurrent to minus 1 mod of n. Very simple. What is the shortcut tips? If you remember my earlier theory, this result I have told you is as a Wilson theorem. What is the Wilson theorem is? This result holds if and only if n is my prime. Fine. Now look at that, which of the following case is my prime. So p is my prime. I can choose p is my 2, k is my any number. Say k is my 2. So is it prime? This number will be 4. 4 is not prime. P and q are the distinct prime. I choose p is my 2, q is my 3. These are the primes. If you product them, it is not a prime. P, q, r. Again, p, q I have taken as a 2, q as my 2, 3, r is my 5. They are my distinct primes. The product will be my 30, and it is not a prime. P is my prime is the only right answer of this problem. Fine. Okay, how many elements does the set? Now again, they are talking about the how many elements. The same method as I told you, how many elements. But in this case, it's a linear equation. But right now, the equation is in the power. Don't forget that it's a complex number, whatever there. It's a complex number, real number, there's no problem. So look at that. If I call this is my m, collection of all those x such that x raised to power n is my 1 and x raised to power k is my not equal to 1. For k is lies between, instead of the 1 I can say 0, 0 to n. Fine. Whenever this condition will satisfied, then the number of the element, that's the cardinality, will be my phi of n. That's the only shortcut tips for this kind of the question. Now look at that. I need a plus 1. Fine. So first of all, it is not a plus 1. How you can make this number as a plus 1? I can scale them. It will be my 120. It is my plus 1. Also, I need a x raised to power k as a plus 1. Again, it's a minus 1. I can again scale them. Z of 2 raised to power k is my plus 1. Then I need whatever the power of k, it must lies between 0 to n. I can multiply by 2 because I need a 2k. Now you can check about that. Whether all these properties satisfied. N, what is the power of the n? 120. Satisfied. K is my 2k. So what is the right answer of this? Phi of 120. Now you can compute the phi of 120. I can make them as a factor. So it will be 2 into 60. 2 into 60 means 2 into 30. 2 into 30 means, how you can factor them? It will be 2, then is 60. 60 will be 2 into 30. 30 will be my 2 into 15. 2 into, so that will be my 2 raised to power 3, 2 raised to power 3, 3 into 5. So then how you can compute the 5? So that's a 2 raised to power 3, 3 into 5 into 1 minus 1 of the first prime number, 1 minus second prime number, 1 minus third prime. So what is the answer of this? If you multiply them, it will be my 120 into, it will be my half, it will be my 2 over 3, it will be my 4 over 5. So 6, 20, 4. So 4 to are 8, 8, 4, 32. C is my right answer of this problem. A very simple shortcut tricks for you, that is my this. Okay, what is the cardinality of the set? Again the same approach. Fine. Again you can apply the same trick. Make sure xn should be the plus 1. Xk should be not equal to plus 1. You can see it is my plus 1. So in this case it is my plus 1 and again a plus 1, and in this case instead of the n it is my k. Fine. So k, all these properties satisfied. So what is the right answer of this? Cardinality of this will be my phi of 98. So what will be the phi of 98? It will be my 2 into 49. 49 is 7 square. So now you can write this number is first prime number 1 minus first prime number 1 minus 1 over 7. So 98 into half into 6 over 7. 49, 7. 7, 6, 42. C is my right answer of this problem. You can see it's a very simple approach. You can solve this with the help of the several shortcut tricks in this video. I request you don't forget to like and comment on my video. Also subscribe my YouTube channel. Now what is the shortcut tips? Now they are talking about the concurrence. What is the shortcut tips? As I told you, always find the GCD of this. What is the GCD of 27, 37, 1. Fine. So this equation has a unique solution. This if and only if whatever the GCD, it must be divide the a minus b. Fine. So for what value of the a minus b? You can see 1 is always divide. It is true for all a and b, because whatever the number of a and b, 1 always divide them. So that means this equation has a unique solution for all a and b. Now you can read the statement. For any integer a and b, let n a b denotes the number of the positive integers less than of the 1000. So clearly say, firstly we can see what is that 27 into 39. It's a less than of the 1000. Fine. So that means this problem has a unique solution. So how many solutions you have obtained? N of AB will be my 1. So 1 for all A and B. There exists is a 0. Wrong. For all AB, yes, 1. Because uniqueness. It is not unique. There exists greater than and less than. Fine. So the right answer is only B is my correct answer. Look at this another one. Given the integers A and B, and AB denotes the number of the positive integers less than of the 100, and you can see 11 and 9. GCD of 11 and 9 is my 1, and also 9 into 11, 99 is less than of 100. So now when this system has a solution, when 1 divides the constants a minus b, and it is true for all a and b. So again n of a comma b will be my 1 for all a comma b. So n a for all integers satisfied, greater than 1 not satisfied, is equal to 1 not satisfied, 0 and is not satisfied. You can see that this is December 2018, this is December 2013. That's why before going to the examination, you must solve all those PY questions deeply. Very repetitions are always occur, but after a certain period of time. Okay, which of the following statement is my false? Again, you can see the first case, 2 solutions occur. So firstly we will see about the GCD of 1000, 6, 7, 8, 9. Fine. So what will be the GCD of 6, 7, 8, 9 and 1000? So you can find it easily. 6, 7, 8, 9, 1000. It will be 6. So 789 is the remainder. Then it's a 1000. Then it's a 789. It's a 1, 1, 2. Then it's a 789. This is the way you can find the GCD. Then it will be by 3. It's a 633, 6, 5, 1, 2, 1, 1. It's a 156, 5, 5, 156, 53, 155, 1. So that means the GCD of this will be my 1. Fine. This is the way you can compute. Otherwise, you can start with this way. 1000, 6, 7, 8, 9. There is no common divisor of these numbers. Now, once the GCD is 1, so when it will be the solution? When 1 divides 23 minus 45. That's a true, because 1 always divides. So this statement is my true, but we need a false statement. Look at the second option. GCD of 1000 and 6, 7, 8, 9. Again 1, and 1 is again divided by 23 minus 54 or 54 minus 23. Yes, it is also my true statement. Look at the third option. You have to find the GCD of 1000, 9, 8, 7, 6. Fine. Or how you can find the GCD? Either you can use as a prime factorization also. 1000 means 2 in is a 10 raised to power 3. So that means 2 raised to power 3. Fine. And 9, 8, 7, 6. It will be 2 into 4, 9, 3, 8. Again you can multiply by 2. It will be 2, 4, 6, 9. 2, 4, 6, 9 will be easy divisible by 3. So if you divide by 3, it's the 3, 2, 8, 23. Then it will be my 8, 2, 3. You can see anything common. You can see from this case 4 is my common. So GCD will be my 4. Fine. Now once you know the GCD is 4, when this solution has when 4 divides 54 minus 32, that means 4 divides 22. Fine. So is it possible? No, because can you find as a 4 times k, where k is my integer? Is it possible? No. So that is my false state. Look at the last case. Again 1000 and 9876. GCD is again my 4. So your target is 4 divides 44 minus 32. That will be 4 divided by 12. So you can see them. You can easily find the number which is k. K will be my 3. So this is my true statement. The only false statement is my C is the right. Okay, look at this another one. N is concurrent to 1 modulus 7. N is concurrent to 4 modulo 15. Then which of the following statements are my correct? First of all, you can see that 15 is not a prime number. So I can break the given modulo. The given one is n modulo 7. This 15 break into the 3 and 5. Fine. So when I taken as a 3, what is the modulus of the 4? Is my 1. And modulus of the 5 with respect to 5 is now my 4. Fine. Now look at that. N is concurrent to 1 modulo 3. Satisfied. 5 is a 1, but we need a, what is the 5? 4 will be my minus 1. Fine. So this option is cancelled. Now you need as a 35 and 21. Always remember, whenever you have a modulus like of these two quantities, your target is to write ax plus by should be 1 always. Fine. Now how you can make them? Firstly, I will tell you about the 35. I need this one and this pair. What should I multiply this 7 with the quantity plus 5 of this quantity so that it will be 1, and that x and y must be my integer. Integer can be positive, can be negative. So can you find the number? You can see 7, 3, 21, 5 and 4, 21 and 4. Is it 1? 21 minus 21. So that means yes, the system has a solution. Fine. Then how you can find the solution? So because in this case is a n, so that n will be 7 into 21 plus 5 into, fine, into, you have to multiply this by, this is my 7 and other number will be my 5, so you have to multiply this by the opposite quantity, and this is my 5, the what is the opposite quantity is my 1. This will be my modulus of 35. So what will be the answer of this? 84 minus 20, that is my 64. What will be my 64 modulus 35? Is it 1? No. Fine. So that will be my wrong answer. Fine. Now look at this second option. That is my 50. That's a 21. So I need these two quantities. Fine. So how you can make them? 7 into something plus 3 into something. That must be my 1. Can you think about the pair? If I taken as a 1, 7, it is my minus 2. 7 minus 6 is 1, satisfied. So therefore, my solution will be 7 and it will be my minus 6 into 7. The opposite of this number will be my 1 and opposite of 3 number will be my 1. This will be my modulus of 7 into 3, 21. So that will be 7 minus 6, 1 modulo 21. Yes, this option is the correct option. A and C are my right answer. And you can see it's a recent year examination and how many seconds you are needed to solve. Okay, which of the following interval contains an integer satisfying the following concurrencies? Again, you have the three concurrencies. Let me check firstly, all are prime, prime, prime. Fine. Then we can try to solve the first two equations firstly. How you can solve the first two equations? I need a 5, I need a 7. I have to multiply 5 by something, 7 by something, so that it will be my 1. Can you think about that? 5 into 3, 15, 7 into 2, 14. Fine. So therefore, my solution will be 15 into something and it will be my minus 14 into something. So that something will be, is a 5 and 7. The opposite of 5 will be my 3. Opposite of 7 will be my 2. Modulo 7 into 5 is 35. So that is my 45 and it is my 28. So this number will be my 7, 17. 17 mod 35. Fine. This is my first solution. Then I can solve this equation with the remaining one. You can solve this problem also by the Chinese remainder theorem, but that will take a lot of the time. So that's why I'm trying to solve this problem in a easier way. Then 35 into something and 11 into something, that should be 1. Fine. So how you can think about that? So if I choose as a 2, then it will be the 70. Can it be the 69? No. If I choose as a 3, 35 into 3 is 105. Can it be the 104? No. So if I choose as a 4, then 35 into 4 will be 140. Can it be 139? No. If I choose 35 into 5, then it will be 175. Can it be 174? No. 35 into 6 is the 30, 180. Can it be 179? No. It's a 30, it's a 210. Can it be 209? Yes. If you 6, can it be 209? Yes, obviously. If you multiply this by 19. Fine. 11 into 19 is 209. So you can see this satisfied. So my final solution will be 35 into 6 and it will be 11 into, so the opposite sign will be, it's a 35, opposite sign number will be 4 and opposite number will be 1, modulo 35 into 11, 385. Now you can multiply them. 35 into 6, 210, it's a 840 minus 11 into 19, 209 into 17. So if you multiply them, 209 into 17, you will get as 3553. So if you subtract them as a 840, you will get this number as minus 2713 modulo 385. Fine. So once you will get this number, now if you divide the 385, you will get as minus of 18 modulus 385. But I need all number as a positive. So I can convert into the positive. I can add them. It will be my 7. It's a 6. It's a 367 modulo 385. So 360 not possible. Fine. Now how you can find the other numbers? Once you know, so my solution will be 367 plus 385 of the k, where k is my positive integers. Fine. So if you take a k is 0, 367 not possible. If you take k is equal to 1, then your x will be 12, 9, 9, 6, 15, 752. 752 lies in this quarter. So then next one, I can add k is equal to 2. I can add 365 more. It will be 1137. So 1137 not possible, 1137 possible. So B and D are my right answer of this problem. Always whenever you have the system of the equation, try to solve by this shortcut way. Okay, again you can see you have the two solutions, but you can see the GCD of 5 and 5. What is the GCD of 5 is 5, and it has a solution when it divides my 3a minus 4b. But this is not true because the coefficient of the x and x are not same. Firstly, try to make the coefficient as the same, and then we can use as the GCD rule. You can see 2x is concurrent to 3a mod 5. Can you make them as a 1? Because I need this number as a 1. How you can make them as a 1? If I multiply this by 3, 6. 6 modulo 5 is 1x. 9. 9 is my 4a. 4a modulo 5. So this is my first expression. Second expression is 1x is 4b modulo 5. Now you can see GCD of 5, 5 is my 5. This system has a solution if and only if 5 divides 4a minus 4b. That means 5 divides a minus b. But you can see 5 is not divided by 4. So that means 5 must be divisible by a minus b. So a minus b is divisible by 5 is the correct option. Fine. Now, whether these options are correct or not. Now they are talking about the particular values of the a, b. So that means we need to find the solution. Fine. So how you can find the solution? Again, it's a very simple approach. How you can find the solution? Let's see. Or I can start with this. Since 5 divides by a minus b. Fine. So that means a minus b is my 5 times k, where k is my positive integer. Fine. Now, if I choose k is my 1, so that means first case. Let me clear this. Fine. So, look at the cases. If k is equal to 1, then a minus b is my 5. Also, it is given that a plus b is equal to 24. Fine. Then, what is the value of this? If you solve them, if you add them, it's at 29. A will be my 29 over 2. But this is not possible. These are my integers. This is not integer. So k is equal to 1, not possible. Let's say k is equal to 2. Then a minus b will be my 10. A plus b will be my 24. So that will give you, if you add them, it's a 34, that's a 17. Then b will be my 7. Fine. So look at that. 17 minus 10 satisfied. Look at the second option. A is greater than 3b. 17 is greater than of 21. Is it true? No. 3b. 3b is my 21. Is greater than 17. Is greater than 14. Satisfied. But this is one particular example. Fine. So now look at the other case. Because we have the infinite cases. K is equal to 3. A minus b is equal to 15. A plus b is equal to 24. Then again, you can see a is my 39 by 2, which is not the part of integers. Because I need a maximum 20. K is equal to 4. A minus b is equal to 20. A plus b is equal to 24. So from this case, I will get this number is my 22. Fine. And b will be my 2. Fine. So then 22 minus 2, 20 is upper limit. Fine. So this case will satisfied. 3b. What is the 3b? 6. Is it satisfied? No. So this option is cancelled. Fine. So the right option is A and D are my correct answer of this problem. You can see that it's a very, very simple approach. You can solve this problem in a simple manner. I hope you can like and comment on my this video. We will see the next part. That's the part 2 on the number theory. I hope you can like, share and comment on this video. Till then, best of luck students. Happy learning.